our game has 10 of each of these entities, the gold and the diamond. So we can create a simple loop that will do that for us. So for x in, we'll go 0 to 10, and we'll just open up this loop, and that will create 10 of these entities for us. We'll create 10 gold and 10 diamonds. And we get an error here because since we're creating 10 entities and they're each trying to take ownership of this data, there can only be one owner of data in Rust. We gotta clone this data, clone this texture, so that each of them get a clone of the texture and none of them own it. And now we should have 10 of these textures, but they'll all be at the very top of the screen, and they have a random position. So now we can give them some logic and start moving them down from the very top of the screen to the bottom of the screen. So we can do it. Start from the top, come down all the way to the bottom. If they hit the bottom of the screen, they'll go back to the top. So we won't free any memory. So we'll just keep reusing the same entities and keep resetting the positions randomly. We can do that by creating another system function. So we'll call this, we'll create one system function for the gold and one for the dynamite. So we'll create the gold first, and we'll call it move gold. And we gotta pass a few things into this. So we have to get the time so that we can multiply their speed by this delta time that's already exists. That's a resource. So that the speed of the entities will always be consistent no matter what device you see it on, you play it on. I'm gonna create a query, and I wrote about the query in the blog. So we have type query. So now we gotta pass two things into this query. So our query is gonna look for any entities that have the component gold and the component transform, since we'll use the transform to move the translation to move its x and y axis, right? So we'll take a copy, it will borrow gold, and it will make a mutable borrow of transform so that it can actually edit the transform. Gold doesn't have any data, so there's no point of us taking it immutably. Now this query basically returns a list of all of these entities that match this specification, right? You gotta loop through it, and returns two things, right? It returns a tuple, it returns a gold, and a transform. So we're not doing anything with the gold, but we are doing something with the transform. So we'll take transform mutably, and we can name these whatever we want. Our query is mutable, so we have to specify that, and we'll call the iter mutable function, and now we have access to all of these entities, and we can just move every single entity from the top of the screen where they are to the bottom of the screen now. So we can go transform translation, and we can get its y-axis. Then we can add, or we can minus, I guess. We can minus 200 multiplied by the, I'm using a random number. You can use any number you want, but I think this is fast enough. So minus 200 from its y-axis, and it will keep moving it down, and it will multiplies it by the delta time, the delta seconds, so that there will be a consistent movement. Now we can check now if the entity hits the bottom of the screen, we'll reset its position, its x and y-axis. Its y-axis should be higher than the top of the screen, and x-axis could be anywhere. So we'll check if the transform that translation, check if the y-axis goes less than negative 300, since that's the bottom of the screen. Then we're going to reset its y and x-axis. For the y-axis, we can assign, and we can just get the code we have here. Right here, so we'll just give it the same thing. And we'll do the same thing for the x-axis. That reset their position. Now they have a random position, and when it goes to the bottom of the screen, it'll reset its position, go back up to the top of the screen. Now that we've created this some logic for the gold, we have to also add this this function into our world as a system. And this function right here setup was added as a startup system that runs only once. But as we're doing logic, we want to check if its position is negative 300, we want to move it back to the top. And we're going to always move it once every frame, basically. We have to add it as a system, and the system differs from the load startup system. So that startup system will run once, where the system will run once per iteration of the loop. Now, if we run this code, we should see these gold coming down from the sky. And when they hit the bottom, they will go back to the top. My view, and you can see it right here, right? Now they're starting from the top somewhere, and as soon as they hit the bottom right here, when my mouse is at 300, their position is reset to the very top. So there's always only 10 of these, but no one needs to know that other than us, right? We can add as many as we want. And we can do the same thing now for the dynamite. So all we have to do really is just copy and paste this function. It's going to be the same thing really, right? Call this move dynamite. And now we want a dynamite component. So none of this should really matter. Everything else should pretty much be the same. There's no difference. You can add this as well as a system in the same way we did. And the Rust does the hard work really. Bevy does the hard work for us. We just add the function and call the dot system on it, and it will do its job behind the scene, turn this function into a system that runs once every iteration of the game loop. So now we look at the output, we see both. We're seeing the gold and we're seeing the dynamite falling down from the screen. And now we can change we can start giving some movement to the player as well, so the player can actually move around the screen. We've got a movement for the dynamite and gold. Now it's time to give some movement to the player, some logic, get some input for the player. We can write a system function to get input from the keyboard and move the player left and right depending on which keys they press. So call our function move player. And we're going to take the time again, and that's a resource. Also going to we're going to give the keyboard input. Call variable keyboard input, and this is a resource that exists inside of Bevy. Input, and we want the key code. And we're going to do a query like we did before over here. So you can just copy and just use this here. The only difference here is now that we're not looking for the dynamite, we're looking for the player. And another difference is that with the dynamite and gold, we were returning multiple entities, where the player we're only returning one player that exists. There isn't two players. So we can give the player and a mutable transform like we did before. That's what we'll call them. Assign it to a query that single mutable. There's only a single instance of the player. Now we can check if the left and right were pressed on the player. Do that by saying if keyboard input that we got pressed, and we can check if the key code was left. And you can take the same if statement, just paste it again, change the left to the right. Now we can do the translation, the x-axis from the transform, and we're doing left, so we have to minus from the current position, and I used 580, so you can use any number you want, but I think this looks smooth enough, it's fast enough. Again, we could just copy this and paste it here. Instead of minusing, we're adding. Yeah, that's all we really need. Now we just have to add this function as a system again, so that it runs once every iteration of the loop. It's going to check if the player entity exists in the game world, and it does. Then it's going to check if the left was pressed or if the right was pressed, and then we'll move the player based on that. We can run and check with an error, and that's because these are integers. We gotta change this to float. Now it should run. Before to show the output. And now we should see that we're able to move the player by pressing the left and right arrow keys. We have no physics right now. Everything's just moving down. Next, we're going to add some physics so that if they hit the player, if the dynamite hits the player, we'll minus 1 money, 1 point from the player. If the player gets the goal, he gets 1 point. And we have to display the text for that as well.